Hi there, my name is Levi Starrett. I want to present the results of the chess tournament and give some details about the model that was used to run that. So I want to give some background first, just reiterate a little bit, show you the tournament runner model, and then we'll discuss the results. So as was said before, this all came about just from getting into chess with my son Ezra. Two major goals for this project was to give mileage on the textual xtUML and Bridgepoint, and also to engage the community. And I think that we achieved both of those goals. Here is a screenshot from the issue tracker. We had 5 distinct implementations participate in this project. 2 architectures, Sierra with Java and MC3020 with C. We had all implementations utilizing the textual xtUML build of Bridgepoint, so that was great. 45 new issues were raised and 27 were resolved, and the rest are still there waiting to be resolved. So we accomplished the goal of getting mileage on the tool and finding lots of issues. So I want to show you about the tournament model. Here's the class diagram. We start with this tournament class here, which kind of centers the model. A subclass of this is the arena tournament. I'll explain that format here in a little bit. Participants are contained within a tournament, as well as games. And participants participate in games through a participation. When participants are not playing a game in the arena tournament format, they sit in the lobby and wait for another matchup. And as they wait, the time gets logged so that they can be determined and matched up based on how long they've been waiting. So next I want to show you the state diagram for the arena tournament. So in the arena tournament format, there's a fixed amount of time that the tournament runs for. Players get matched up against one another, and when they're done playing their matchup, they go back into the lobby where they wait for a new matchup. So we start by creating the arena tournament, and then in state number 2, the tournament will put all the participants in the lobby. Once that's complete, we go into the service lobby state, and in this state, the tournament is selecting players to match up, and as long as there's still players left in the lobby, it loops back around to match up more players. If there's no players available in the lobby, or if there's no suitable matchups, it will go into this waiting on games state, where it waits on tournament games to finish and players to re-enter the lobby before it can make another matchup. When the game is over, it goes back into the servicing lobby state and tries to make a new matchup. At any point, if the time in the tournament runs out, we go into the time is up state, and there we loop over and over, checking as games complete, to wait until all games are complete, and then once all games are complete, we go into this completed state where we output the results. The main logic of the tournament runner is in the servicing lobby state. I'd like to discuss that a little bit more later. This tournament runner was never actually generated to code. It was run completely in Verifier. So here's a screen capture of that running in Verifier. 4 of the implementations that participated in the tournament were run on separate EC2 instances with identical specs. So we had the 2 of my implementations, one running under C and one running under Java, the example model, and Quartz Max Advance. Alistair's model was also running, but his was running in Verifier as well. And as the tournament is running, I was able to monitor the games in progress. Okay, now I want to show you a demo video of this. Demonstrate running a tournament. So I have the tournament model opened up here in Bridgepoint. I also have Alistair's implementation running in another, in Verifier in another instance of Bridgepoint. And I have 4 other implementations running on individual EC2 instances on AWS. So this one is my implementation running generated for C with MC3020. This is my Java implementation. This top right one is the teacher model, and the bottom right one is Quartz Max Advance model. So I'll go ahead and start the tournament in Verifier. So it starts up and it creates an instance of tournament and creates all of the instance of participant. So if I look under participant, I have my 5 instances here, and then I have my arena tournament instance and my tournament instance. So I'll go ahead and start this by right-clicking and executing the start operation. So it starts creating matchups, and if I look over in my browser, I can see that those matchups have started. And this one, it looked like was the one of QuartzBot's versus my implementation. And then you can see as it goes, here's my implementation running against Alistair's implementation. And this one is waiting at the moment. So if I go back to Bridgepoint, I can see in the lobby, there should be one person waiting. So yeah, Cortland Stair at B2 is waiting. And then down here I can see the instances of the game. So there's 2 instances that have been completed. There's a completed one. There's an in-progress one, so I guess there's 1 instance that's been completed and 2 that are currently running. And we can see how those ones are going. We can also look at the process or the progress of the arena tournament, so I can print the time remaining in the tournament, so 8 minutes left, or 8 or 9 minutes. And I can also output the current results. And I'm going to go ahead and time this out early, which is going to cause the time to be up, and as soon as the current games complete, then we will be over. So we need to wait for this game to complete, and then I believe this game here against QuartzBot and MyBot. So that one may have stalled. Yeah, it looks like we had an issue here, so let me get that going again. There we go. And it looks like the Levi bot over here won, so we're still just waiting on this game to finish. And there it's over. So if I go back to Bridgepoint, it's printed out the total time that we spent was 3 minutes and 29 seconds. And here's the order of the leaders, as well as their individual performance against each other, and then the games that involved in the tournament. And that's it. All right, welcome back. So I want to review the results here. I ran a tournament that was 30 minutes long, and with these 5 participants, and these were the results. There were several insights that I wanted to talk about. I also have provided a link if you want to go browse all of these games. You can look at the individual games. They're all stored on Lichess. One thing that you will notice is there's a bit of a correspondence between average game duration and and score, and we'll look at that in a minute. Some interesting insights. So the arena format, as I was mentioning, speed of play matters almost as much as the quality of moves, because the quickly you play, the more games you get to play and the more opportunities you get to score points. If you're going to sit there and think about a move, you better come up with a good one. Fairly assigning matchups is pretty difficult. So if you look through the information of all of the games, you can see that I tried my best to write the logic to match people up with the fairly. A couple rules that I employed, I made it so that you couldn't play the same person back to back. And also, when you were matched up with a player, it would check to see how many times each player had played white and black against one another and assign the colors based on that. But even so, with this few number of players, there were certain players that played many more times with other players, which gave them an advantage or disadvantage in the tournament. So it was very difficult to get fair assignments. If I was continuing to work on this, I would probably include some sort of assignment based on matching people with similar scores. Also, like I said, the longer you play, the more you're out of the tournament and you're not getting matched up because you're spending too much time in more than one game. Successful bots need to capitalize on advantages. So there's a huge difference between the middle game where you try to take pieces and the end game where you try to perform a checkmate on your opponent. So this is a screenshot from one of the games that Alistair's bot was playing against the random move bot. And you can see Alistair's bot has an overwhelming advantage and has taken all of White's pieces. But it still ran out of time and was unable to checkmate Black in this situation because it was still looking for more pieces to take. So this was a very common occurrence with Alistair's implementation. And that's all I have. If you have any questions, feel free to let me know. Thank you.